for the next box.
Oh, I forgot the computer.
Okay, we're live.
Mm-hmm.
Are we live, gentlemen?
We are.
Can I talk now? Are we recording and we're on YouTube and everything? And let me adjust.
Yes, and yes.
I didn't see the second little box.
Okay, it's up
And
there
I'm
somewhere.
not sure about the screen layout, but hello, everybody. Santa Barbara Astronomical Unit is on the air. Another telecast bringing to the internet by way of YouTube, the SBAU Astro Hour. It's number 176, well into our fourth year. It's a weekly cosmic vlog podcast on everything that's going on in astrophysics these days for a whole hour. Our longtime telescope club, headquartered at and supported by the beautiful Santa Barbara Museum of Natural History up in Santa Barbara's Mission Canyon. General meetings usually held on the first Friday of the month, 7 o'clock. And although replaced this last Friday for this month by our summer potluck, first we've had in years, this coming Saturday, July 13th, will be our 4:30 planning meeting online, followed by the 8 o'clock star party. $20 to join in a year. And I'm Ron Heron, your host. We'll meet the rest of the board and some stalwart members in a minute here. Today, what is today? The 8th, July 8th through the 14th, number 176. These are the cosmic topics on tap. Into the night sky we go again with Hercules, the Aquila or Aquila, depending on how it's pronounced, constellation, the flying unicorn. We have a magnitude 1 star about to vanish this week behind the moon. Might happen during next Saturday's star party. Where is the whale galaxy? For crying out loud, how do you lose a whale? We're going to show you. We've got to track a dwarf planet. It's not Pluto. Boy, I sure wish I'd get my radio voice back from the shop. These damn loners they give you are never any good. We have an update on Comet Oberts. It's crisscrossing into Ursa Major, and James Webb takes a selfie. Maybe if we're lucky, we'll get a look at T Corona Borealis and Asteroid Pallas. We could do a poem with those two through Jerry's photometric observation. Listen to this voice. I'm losing it already. Help me, gentlemen. Let me introduce you. President Jerry, about to go on vacation. Jerry Wilson, married to the lovely Pat Forgy.
Good morning.
Not much of an eater, but he wears a great wide brim hat. You reminded me of the Colin Taylor era in the Treasury. That was Friday night and today. Thank you, Jerry, for running the program here. Captain of the Starship. Chuck McPartland, the cat man, is also our outreach coordinator in front of the Ukraine flag. His wife is also a Pat. Pat McPartland is merchandise manager as well as treasurer these days. We have Bruce Murdoch on screen. He's married to Bonnie, happens to run the Santa Barbara Theater Organ Society. And whenever things are happening over there that we should know about, please feel free, Bruce, to interrupt me. And happy birthday, incidentally.
Thank you.
39 again, or you're actually...
Well, the organ is hurting right now because the computer monitor burned up. The horizontal output transformer smoked. And I've been trying to find it. It's only 35 years old, so...
Oh, okay.
I'm trying to find replacement parts for it.
That new equipment just doesn't hold up.
Okay, you do try. Don't have as much fun as we do here. Okay, and he's married to Bonnie, as we said, and Tom Whittemore is married to Maureen.
Right.
Edits our newsletter and used to run a dynamite lab out at Westmont College. Tim Crawford is married to Karen. Were both of you there? Was your wife there at the Friday night?
No, I didn't make it.
No.
Oh, you didn't even make it. Well,
No,
no wonder there was food left.
So Ron, we had COVID, for the first time in my life. And so I just didn't want to jeopardize anybody. That's why I stayed home.
Oh, sorry to hear that. Didn't know.
I think I'm fine now, Jerry. But
Okay.
this thing has lingered. It really has lingered,
Yeah.
Well, it's not a long-term thing. You recaught it. You haven't had it all along. There's some nasty cases.
Hey, Tim, I was going to ask Tim if he would put up his greeting again.
What greeting?
Tim?
Well,
Yeah, do you know what that is, Ron?
2 fingers?
You know what it is?
2 fingers to me. Is it double the?
No,
one?
it's Julius Caesar ordering 5 beers.
Okay. Yes, so one of the things we're about to put up with is Jerry's cartoons and Tom Whittemore's puns. So let's go to the
Yeah.
silly stuff.
Come
Yeah,
on,
guess which one of us took Latin?
Yeah. We start with a little levity,
years.
continue it into the cosmic sphere. Oh, this one I had a little trouble with, but I think I finally got it. Modern day science versus science fiction shows, I guess, the reality on the left, regular science, guy in a lab coat carrying documents next to his file cabinet and a potted plant versus, whee, come on over, you know you want to. That's R2D2 and knows that strange man in the cut. Yeah, I guess it's going to be a fun.
When I was a kid, the first thing I started reading was science fiction. Got me very much
Isaac
interested in
Asimov.
science.
Well, is the upper right part of this cartoon, is that New Scientist, the cartoon or the magazine you got it
That's a
from?
cartoon
Oh, okay, by Tom
written
Gold.
by Tom Gold.
Oh, yeah. Well, you know, we've got to have the science fiction. I never grow tired. The Westerns I've gotten tired of. They're not real. Okay, here's the woman talking to her husband in the living room. This gets a little philosophical, so hang on. Oh, wait a minute. Backwards. Okay, she says, you know, honey, when I ask you what you're thinking about and you say nothing, is that
I like this.
is that nothing as in infinite void, the emptiness of Zen, the nothingness of Sartre and Lacan and Albert Camus and the stranger and existentialism, el nihilo nihil fit, or what? Talk to me, doggone it, honey. Okay, a little philosophical.
Good point.
What?
It's a good point.
It is. It's thought-provoking. Makes us think. And there's a cat in that, and there's sort of a cat in this one.
This one's good.
Okay, the hovering extraterrestrials are the one-eyed creatures inside their spacecraft looking down on a black and white creature. Sure, one says to the other, abducting a small black and white animal should be safe. What is that down there? A penguin?
But they don't have noses. They don't have
No,
to.
they don't have noses. Is that the point? They can't smell it?
No, they have beaks.
What?
They have beaks.
Oh, I see.
They're birds.
These are two ladies at a party, and they're looking over at I guess, an event horizon. And she says, "You know, ever since Richard collapsed into a black hole, people just seem more attracted to him."
Yeah, look at the cat holding.
Look
on
at the
there.
cats. Yeah.
Oh, it's cats are going to be coming up a lot here in a minute, I think, because we love cats. Here is new signs of life on Mars. They either had their own Roman Empire or an extension of USC's Trojans. And I
No,
guess
this is from the Warner Brothers cartoon, MGM cartoons.
oh, is that one?
This is,
Yeah.
Marvin the Martian.
Yeah.
Little Martian, yes, we remember.
Where's
Okay.
his ray gun?
Yeah,
Yeah,
here's
that's
all right, cats from space here. This could have happened in the past, you know, these 6 boxes. There's an invasion from space, large kitty litter pans are landing. And sure enough, the doors open and we're being invaded. What are we going to do? Help. And Chuck's kitty cats came out. And somehow they made us slaves. By the bottom, I can barely read the words, but you got the message. We pet them, we take care of them. Pretty much they own us. And I'm waiting for that black cat to walk across the screen, Chuck, in front of you in the
She's
flag.
back here.
Always behind you. And you talk about love, the man is allergic to him. Okay, this is interesting. This is real. This actually, I guess, was on somebody's screen thanks to AI. I don't know what city this is, he says, but look, they're all going to die on Thursday. But in
Thursday, the temperature is going to be
You know,
379
I missed that.
degrees.
You know, can I pause things just for a minute and tell you a quick story about when I worked at KAFY in Bakersfield in the 60s? To get the outside temperature, since you're doing the news and you follow with weather every hour, you got to have a little temperature sensing node or nodule hanging under the eave of the radio station. Currently downtown in Bakersfield, and you look over and it says 78 degrees. We used to go with our Bic lighters. And the poor guy would say, currently it is 180. My God, Margaret. One of the many things we used to do. Okay. Any more, Mr. President?
No, that's it for those.
Quality.
Our offices at Comtech used to be above where the Secret Service had their offices at one time. And so one of our guys, just for fun, Xeroxed a couple of $20 bills and put them on some fishing line and lowered them down and was dangling them in front of the window of the Secret Service.
Well, I used to do the news on weekends, and the manager himself would come in and turn the light off in the middle of my newscast and open up a porn movie right in front of me on the wall. And I'm trying to read the rip and read stuff off a teletype machine, and oh my God, look at her. Okay, President Nixon said it. Oh, geez, look at that. All right, where are we here? I don't remember this picture.
I
Sure.
added two pictures that I didn't send out on the wire over the weekend, just because they're such cool pictures. Now, this picture showed up on Facebook, but without any kind of citation or reference of what it is. So I don't know that it's necessarily real, but it's a cool picture. I went through looking at the coronas of the 2012, 2017, and 2018 eclipses, and it's not any of those. So it might be the 2024 one. I couldn't get a good read on the corona shape, but it's a very interesting picture. It's very nicely processed, although it could be an embarrassing AI one, but we'll see.
That's really what the sun's corona looks like
I
behind
don't know. It's certainly illustrative. It's certainly suggestive of that. I'll try and track this down if anyone recognizes the corona shape, but I'll track it down and let you know. It's
Well,
just
do you suppose anybody is redoing Einstein's calculation, or somebody proved the thing about gravitational lensing by
Actually-
waiting for a full eclipse of the sun? You remember that?
That was done during the 2017 eclipse
Yeah.
by a bunch of amateurs.
Yeah.
But not for the first time. That's not when they proved.
No, the first time was in 1917, I think.
Yeah.
But they don't do that anymore. It'd probably be very
And
hard.
they do it. Someone does it every eclipse.
Okay, you see
They
stars. in their
tested
movie.
Einstein so much.
Got it.
He's right. This was another cool picture I found. This is a large crack on Mars, and it's on one of the shield volcanoes, real close up. It is a plate of lava here from a previous eruption or flow, and then lava came up from inside Mars under the plate and forced it up and created this crack here. They call it a graben. I'm not a geologist, so I can't explain that anymore.
Graben?
But it's an uplift crack, a crack.
Yeah, it's Grabens, Jerry,
Graben,
Grabens. German for graves, means graves.
Okay.
Die
Someone
Graben.
to get out of his grave, I guess.
Are we looking down from orbit?
Yes.
Yeah.
Oh, yes.
Oh, that's a big crack.
Well, there's no scale here to tell on it. It's blown up pretty well, but
Oh, I
Well,
see.
on
It's
one
very
caption I saw for that photo, it said size of the Grand Canyon.
yeah, okay.
Whoa,
Oh,
well,
so
there's already.
there's a little bar down in the lower right.
Oh, that's
that says-
right. Yeah, 20 kilometers.
Oh my God.
Yeah,
Well,
that's
that-
a big,
Looks like a great place to land a future Elon Musk probe.
yeah.
Right,
Or
that's-
land Elon
that's
anyway.
200 to 300
That's about
kilometers
12
long,
miles.
Yeah.
Wow. But there's a big long canyon on Mars anyway. It's bigger and longer and deeper than our.
Yeah.
Yeah.
It would cross the entire US.
Okay, now to our talking points. Now, this is looking at the constellation of Hercules.
Mhm.
This is the keystone. It's shaped like the very top stone of stone arches from the Roman era or from the medieval era. And in here, the very famous M13, the Hercules cluster is right there. T Corona Borealis is here.
Oh,
So it's
So it's
right
just
near
off the T Corona would be just off that image.
with Sosis right there. It'd be off this image. Here's Corona Borealis right there.
Yeah. But T is down.
Oh, this is
where it's
excuse
cut
me.
off.
This is Tau Corona Borealis.
Yeah, yeah.
Right. Good observation. And then NGC 6229, which is shown here, is this very small, looks like an amateur photo of the globular cluster. But the point is there are three really nice globular clusters in Hercules. The most famous one here gets all the attention, and it'll get a little more in a few seconds. And then M92 is right here. That's another nice globular cluster.
Oh. A keystone is the centerpiece of a
Of
arch.
an arch, of an
Yeah.
arch.
Never understand how they got those up there.
Very
had to-
carefully.
Somebody had to hold it up while they put the other stones to hold it up.
No, what they
Well,
do
they
is
put
they
cribbing underneath it, wooden cribbing that define the arch, and then they put the
Oh,
stones on it, right? And once the last stone is wedged into place, the keystone, then in Roman times they have the architect stand under the wood cribbing as they remove it.
It's like, when a submarine is launched, the designers of the submarine must be on board.
Sounds good to
Yes.
me.
And I guess an igloo has to have several key blocks or whatever they're called in the middle to hold it up, don't they? An
That's a
igloo.
more complicated structure with not a single keystone. It's got a keystone circle at the top to let the smoke out.
Good
Yeah, there's a
Lord.
hole in the top too.
Okay, good.
So this is
Interesting.
a very nice globular cluster. This is M92 taken, I believe this was with the Hubble telescope. Or
Wow, it's a lot of
It
stars.
says
No, it's from
Isaac
the-
Newton Group.
right, telescopes.
Mhm.
Very nice. Resolved on this picture close up, it's resolved right to the center.
Jeez. You suppose some of those stars are only light weeks apart?
I don't know about that. This is pretty far away. They're thousands of light years.
So there's still plenty of land. Okay.
They're pretty close.
Yeah. And this is an amateur drawing of M13 showing the dark things that are called the propellers.
Mhm.
Very prominent visually, but you never see them in photographs. They're filled in with stars.
Mhm.
And is there a date on that? For
Looks
when
like a bat.
it was made with a 6-inch Newtonian.
Hmm.
Yeah, so it's a recent one. Eric Grapp. It's not, but this is what it would have looked like in a 6-inch Newtonian in the 1800s. So,
Is that right?
yeah.
Imagine what the web would see.
The what?
Imagine what the web would see. We're going to see a selfie from the web later, aren't we?
I think
Yeah,
I told Jerry that the propeller, I always thought was the stars that were prominent and not an absence of stars. So
Yeah.
this was something that really stood out to me.
I don't think it's an absence of stars. I think like most dark things, it's just an odd pattern of dust obscuring the cluster.
Oh,
Oh,
okay.
it's not the arms that are the propeller wings. It's the middle, that dark part.
The
Yeah.
dark part, yeah.
Yeah.
I'll be
It's
damned.
three
And I
parts.
was always looking for stars, Ron, like you were. I was always doing that. And I said, I don't see it, Well, it's
So this
here-
is very
here it
close to what you will see in an amateur telescope visually.
Yeah, I mean, usually it's a little more filled in than that. As far as the spots that are empty up at like 11 o'clock and 10 o'clock.
Yeah.
Well, this picture is lacking color of any kind. There might be blues and
It's
reds
a
and
drawing.
yellow.
It's a drawing, Ron.
This is a drawing?
Yeah.
Yeah.
Well done. Looks
Yeah,
like
it's a good job.
Okay.
Now this one,
In a galaxy far, far away, far in the future. Where are we here?
Way in the past.
yeah.
That's true, you're right. Warp speed, engage.
So this is,
This is our flying unicorn.
Oh, this is the unicorn.
yeah, this is the final chart for the unicorn.
Mhm.
Here is the Milky Way along here.
Mhm.
The planetarium program, I guess, didn't want to take the time to draw it down here continuing. But this is Altair, which is distinctive to my eye by the two wingmen that it has here. So it's a little set of 3 stars. So this is how you identify Aquila. And NG 66709 is right up here. This is called the flying unicorn. And how they get a unicorn out of this, because this is it
Yeah.
right here.
No, there's no horniness involved.
I don't know what it is. They
I don't know. I can sort of see it.
I sort of see it too. The unicorn is going off to the upper right.
yeah,
Yeah.
there's kind of like a front legs or back legs, I mean, tail, front legs, head, and maybe a unicorn and horn right there.
Yeah.
So
I guess you can see that too.
It's
it's
one of those
not
averted imagination things.
it's not an asterism that pops out for me. I have
Like
to
the
work on it.
teapot, huh?
Yeah, I didn't see that.
And you've got a wing going way to the back.
This thing here,
Yeah.
I think that's more of a fluffy tail, squirrel tail.
Didn't
Unicorns, they didn't have
unicorn,
wings, did they?
Yeah. Unicorns
That was-
have wings.
Pegasus that had wings.
Yeah.
So
but unicorns came about from the narwhal whale, didn't they? Because it had a long,
boy, I
Yeah.
have no idea.
I see that more at Santa with his hat on. His two eyeballs.
Two eyeballs, yeah.
It looks more like a jester's hat.
Yeah, yeah.
Yeah, it could be that too.
oh, they,
I forgot to ask Jerry, with 6229 in our amateur scopes, is it very visible?
The globular cluster.
Yes.
Yeah, the implication of the write-up was that they're all very visible in the amateur scopes.
Okay. Okay.
okay,
Yeah.
continuing. Are we about to see the whale or we haven't reached that yet?
Looks like the
No,
whale's next.
This is the whale, the fuzzy whale. The
Oh,
whale of fuzzy. NGC 4631 is the whale galaxy. This is near the stuff that's directly overhead in the evenings in the springtime, the Virgo cluster.
really? All those yellow numbers are different stars in one
No,
of
Those are
they're
them?
Messier galaxies.
Yeah,
Galaxies.
Oh, cluster
Coma
galaxy.
Bernices, yeah. And the Big Dipper is up here for locating it. This is hanging down right now. It's should have rotated it so it would look more like the sky.
Mhm.
But if you look on this as an arc, a mirror, then right at the focus of it is NGC 4631. M51's up here, M106, M109, M63, M94. This is a wonderful region to go galaxy hunting. Beautiful galaxies. So this is the whale and the hockey stick galaxy.
Hockey stick, not a hockey puck. We did it.
Well, no, it's more the stick.
I
This
know.
is Ben.
We do need a hockey puck now. It's somewhere in space, gentlemen.
Lots of them, lots of
Yeah.
them. So this one does have a faint representative of a whale shape.
Mhm.
You know, the nose and the bulge and the tail out here. It looks that on a blow up, but I like this one because it shows the two of them at the same time. So
They're both-
that's
They're both edge on spiral.
yeah, yes, they're both.
Be darned. There's also a cigar that's edge on, and the sombrero's sort of edge on, isn't it?
Yep.
Yeah, the sombrero is fairly close yet to on, but this is in the north. Sombrero is in the south.
Hmm.
Sombrero is one of my favorite galaxies to photograph.
Definitely has a bar in the middle that pops up like a Mexican hat. Okay, where are we here? Negative.
We're looking at Ceres.
Oh,
So
to be a planet. Right.
and Ceres is going to be very, very close to M54. So this is a chart of the teapot asterism in Sagittarius.
Okay.
This is the handle. This is the spout. And there's the steam coming out of the spout, which is the Milky Way going up here. And then these are globular clusters. These yellow circles with the cross or the plus sign in the middle of them.
We had that M22 last year out of Bacara, Jerry. It was You remember that? It was just unbelievable.
Yeah, it's a nice globular. And this stuff is really dense for you don't have to really look for things out here. You just point your scope around a little bit. You find
Yeah, they're everywhere.
yeah,
Everywhere.
But we're supposed to find Ceres in there somewhere.
not yet, not on this chart.
Oh,
But if you
okay.
find M54, Ceres is right next to it.
Oh,
This is the path of Ceres.
Oh,
This is M54.
Mhm.
So July, where are we right now? We're at the 8th, right? We're right here.
Aha.
So about the 16th or the 15th, it will be closest to M54.
And it's
that's probably UTC, so you might have to subtract a day.
Yeah.
but no, it's the one of the largest in the asteroid belt, right? It doesn't leave the belt like a comet,
It is the largest.
and it's in the belt. So we're looking at the asteroid belt right there, aren't we?
Actually, it's referred to as a dwarf planet now.
Yeah.
Because it's spherical and it's about 600 miles in diameter.
Well, it would be the largest. There's also Vesta, isn't there? Is that a dwarf?
Alice, Juno, Vesta, yeah.
Yeah.
Okay.
Vesta is not spherical.
Yeah.
It's more of an irregular shape. But
Whereas
just
2024 MK that just passed us was what, 500 feet across or something?
yes. Let me see.
You sent us a
And they
picture.
they found a moon on the other one, on the other passing asteroid.
That's right. You could see it. Little dinky sucker.
Let me just hang on a second here.
Fascinating trip into the cosmos every Monday morning, boys and girls. You suppose when they do the planetarium show and they go to do the teapot, they sing the old song, "I'm a little teapot. Here's
I
my
doubt that.
No, I never would.
Well, it's up there, and that's how kids, maybe they don't teach these kids. Here we go. We sent it these. Ooh, it's moving, Margaret.
Yeah, we were talking about bouncing radar off different things like Mars and Mercury and stuff. And we don't do that. It has to be very close to get a radar return on it. This one has okay, it's stopped for it, but you saw it rotating. That was apparently we ran to the end of the video. But
Yeah, I ran through that, and once it plays through once, I couldn't get it to repeat.
yeah.
You have
So
to exit
this
the
is-
page and re-enter, I think.
I tried that and it didn't work.
Yeah, so I did too. So we're just going to get out of this here. But
Is this the one with the satellite?
No,
this
oh,
is
the smaller one.
one of the two that went by us the last few days.
So this is an actual picture of it moving.
It's a radar image returned from it on a radar scope.
radar.
It was a bistatic radar, was it not? The transmitter was on a satellite and the receiver was on Earth.
Okay.
So it takes a few minutes to get out there and back, doesn't it?
Not when it's that close.
Yeah.
Oh, that was pretty close.
It
Okay.
came between us and the moon, so the moon's only 1.3 seconds.
So like a second away.
Okay.
So we're back to here.
So
Now,
dwarf-
it turns out that we're going to get an occultation.
Oh, here we go, friends.
We're going to get an occultation. This was someone put in a bunch of data into Stellarium and generated this picture. These are from cities. For example, New York City, it doesn't have an exit. I guess they're not going to give it back. But Winnipeg here goes to Winnipeg. Kansas City goes to Kansas City, Seattle. So these are showing the entrance and egress in Mexico City. Now we will see it here in California, but it will be during the daytime. So you're gonna have
Well, the ingress will be during the daytime. The egress will be at 8:54. So we'll be able to see that maybe at the Star Party at the museum.
okay.
Yeah, but it's only 45 minutes after sunset.
So this is at the predicted time of ingress. So don't be fooled by the dark sky. I just didn't, if I erased the dark sky and made it daytime, then the star would have gone away.
Yeah.
So this shows July 13th at 7:38 p.m. local time. The moon Spica should just disappear and then reappear over here later on in the evening when the sky is dark.
Well, the sky won't be super dark, but yeah, it'll be a little before 9 o'clock.
Yeah.
And Spica
Oh.
should show.
And
Yeah.
you don't need a telescope to see it.
Well, when it just egresses and it's close to the limb, you might need a telescope to see it.
Yeah, I think
There's your sombrero, Jerry, right there.
You what?
There's your
the
sombrero,
Mhm.
M104.
Oh yeah, you're right. M104 is right there. So I have looked at planets and stars in the daytime back when I first started on this with a 6-inch reflector. And you can see stars if you know exactly where to look with the telescope during the daytime. If the day is clear, the air is clear. It's only the brightest stars that you can see. Someone
Wow.
wrote up the fact that if you were at the bottom of a well, I don't know how this occurred to them. Maybe there was an accident and he made the best out of it. And you look straight up and it doesn't have a roof over the well, you can see stars in the daytime because it blocks out most of the skylight.
Yeah, I think that's a myth, though.
I've never tested, I was just about to say, I never tested that myself,
Yeah.
but it's in those books that first start for amateur telescope making, books 1, 2, and 3
Yeah.
in the 1920s. But you can see bright stars like this during the day. What I do, especially with like Venus, because they said it was best to look at it during the daytime, the contrast is lower. And so I'd set my telescope about where Venus was going to be at the declination of Venus the next day. And then I would go out with the telescope set up already, and then I'd just swing it a little bit in right ascension, depending on the time. And sure enough, you can pick Venus up.
Really?
Andy Allen, when he first joined the club, he decided he needed a project and he was going to image surface detail on Mercury. And he did it early in the morning when it was daylight because the seeing was good. It hadn't heated up, the surroundings hadn't heated up yet during the day. And so the air was still. And he went up to the top of Mount Laguna and took thousands of images with a little webcam on his telescope and then stacked the better ones. And he imaged surface detail on Mercury.
Wow.
You could see craters like we see on the moon?
Not craters, dark and light features, though, like the mares on the moon.
Mhm.
Wow.
So anyway, mark your calendar, July 13.
Yeah, that's a star party night.
Yeah.
Starting at 8:30, Ron, by the way. You said 8, but it'll be at 8:30.
Well, we'll be there greeting people though at 8.
Yes.
If Betelgeuse up in Orion blows, we'll be able to see that day and night, won't we?
Oh, yes.
Yep.
And also T Corona Borealis.
Well, not during the day.
No. Oh, I don't know.
It's only supposed to get to magnitude 2.
Oh, okay. Yeah, definitely. Otherwise, you'd be able to see Polaris in the daytime.
Yeah.
It's the same with Polaris.
Okay.
Well, I learned 2 new words, gentlemen, I'd never heard in my whole life. Ingress and what's the egress?
Egress.
Right.
Going behind is
Well,
ingress.
The
Coming out.
technical terms for that is the gazinta and the gazouta.
Yeah.
P.T. Barnum put one more on that. You go through his display or his animals and whatnot, and in the ingress, and then he goes to the egress, and then to the tigress. The door to the outside.
And they're throwing a good lioness, and we have a party going.
Yeah.
Fantastic. I learned 2 new words. Never heard them before in my life. Okay, something's on wheels. That's the wheelchair
This
galaxy.
is an asterism that I had never heard about before this.
Oh, yeah.
Oh,
Yeah.
it's the 3 leaps of the gazelle. Yeah.
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 And so apparently this is reminiscent to someone of a gazelle's footprint.
Yeah. Yeah, Jerry, that's an old asterism because it's in my old copy of Field Book of the Skies.
Oh, Burnham.
Olcott.
Yeah.
Oh,
That's in the 3 Leaps of the Gazelle.
okay.
And
It's
usually
really
the that's like the other hind leg of Ursa Major, right?
That's right. Right.
Yeah.
Yeah.
Here it's just isolated. The lines don't go down to it, but
Mm-hmm.
Thank God there's too many lines in this one already. So this is Ursa Major, the big bear, as you just heard. It's above Leo.
Mhm.
And so this would make it a gazelle instead of a bear, but I guess that depends on your culture. And so these are the three, somehow they're involved with the comet Olbers, which is passing in this region
I
nowadays.
see.
Jerry, I called up that great picture of Olbers if you want to see it that was on Space Weather.
Sure.
Okay, let me let's see, I got to do screen share.
Oh, yeah, wow.
Yeah, the tail got hit by, an outpouring of stuff from the sun.
Yeah.
And you can see the charged particles are kind of spiraling around a magnetic field line there.
Mhm.
Oh, yeah.
Yeah,
Well,
this is not just a snake shape. This is actually a spring shaped.
Yeah.
Some of it being closer and some of it farther away.
actually, it's the shape of a large sperm in space. But
Yeah, they have
I'm
a
sure we're going to go there, but anyway,
what, Bruce?
the
what's that?
sperm has a flagellate that they use to propel themselves
Yeah, that's true.
like that.
Well, that is that the tail that's curving? It can't be. It'd have to be
Yeah.
straight, wouldn't it?
That's
No,
the tail.
it follows it's a plasma. The solar wind is a plasma. It's charged particles going out. And so it's creating magnetic fields as it went. A moving charge creates magnetic field. And the charges, the ions in the tail of the comet are responding with the Lorentz force, which is at right angles to the current. So it's giving this corkscrew effect.
And it would be fair to say that the big white blob is heading to the lower right hand side of the screen, right? Lower.
No, you can't judge from a comet shape which way it's going. You can only judge which way the sun is.
Hmm.
See, there's a tail pointed this way. There's a bow shock this way. And the one tail goes back this way. Oh, you can't see my cursor because it's not my thing. But
I was wondering, I got my cursor going, and everybody
Yeah.
else did too. Okay.
okay,
Wow.
thanks, Chuck. That's a very
Mhm.
dramatic photo. The one I have is not so dramatic. Can you see this chart?
Mhm.
Yes.
Okay. So this is the chart of where Comet Olbers is going to be. And here it's July 14 here. So that's our star party is right about here in Ursa Major. And so there's two of the stars of the leap. And there's two other stars.
And then in between them there.
These you think?
No, come up and left near the red
Oh
dot.
yeah, you're right there. Yeah, there it is. Yeah.
Huh.
Now, this is going from the right to the left, isn't it?
It's going this way. So it should be well placed. It's not a bad position for us. Usually for me, comets are irritatingly far south.
Yeah.
Your house is in the way, huh?
No, usually the Earth is in the way.
Oh,
Now this is the picture that I got. I don't mean I took it. Actually, I did take it off of APOD. This was for June 28th. It was the astronomical photo of the day, and it was of Comet Olbers. The CME was just starting or it hadn't got there yet. But you can see that there's a lot of material going out this way. And so it's kind of a tail facing this way. And then there's this tail going this way. So, and it gives the appearance the comet's moving this way, but I suspect that's just the direction of the sun.
And it hasn't flagellated yet, as in Chuck's picture.
Yeah. I would guess that the comet is actually moving this way.
Well,
Holy cow.
you've shown me some circulating or turning galaxies before that you said that were going the opposite way, and I can't buy that, but whatever.
Uh-huh.
Looks like it's
I
heading.
find that to view this sort of stuff, sometimes I make the video inverse. and then the two tails show up quite well.
All the faint stuff seems to show better. Yeah.
Right, right.
Does anybody know what comet in the history of comets came the closest to Earth?
Pally's.
Maybe, probably a Tunguska impactor.
Yeah, the one that down in Mexico,
Yucatan.
yeah, Yucatan,
Well,
right?
that one seemed to be more of a meteorite, but
Oh, that was 65 million years ago, wiped
Yeah.
out the dinosaurs. Okay.
Halley's Comet in 1910, we passed right through the tail. I don't know how close the head was.
Yeah,
Right.
I was gonna guess that one for the ones
Yeah,
that came closest and missed.
And we're
Yeah,
still passing through the tail, right? That's what brings on.
And they had just learned to use spectroscopy to determine the chemical compositions of things in space. And they decided that there were a lot of organic molecules, including cyanide, in the tail of Comet Halley. And so people, snake oil salesmen seized on that and started selling gas masks.
Oh my God.
And cyanide pills.
Certain segment of the population was panicked, and so they bought them up, did a land office business for a while. It's far
You know-
too tenuous to have had any effect on Earth.
Just before I joined the club, there was a comet that was highly visible up in the northwest.
Hyakutake?
Is that what it is?
There was Hyakutake and there was Hale Bopp.
Right. About a year apart.
Yeah.
Well, one was the one was. I mean, it might have been Hale Bopp. It was really big, and
Yeah.
and
Yeah,
you could
that was
walk
in
up like-
97, Tim.
Okay,
Yeah.
I'm gonna look that up because I wasn't in the club yet. Boy, that would have been neat to take out a
Yeah.
telescope and look at that.
Yeah.
When the first one came through, I set up a 80 millimeter refractor in my backyard,
Mhm.
and I got my toddlers up. I said, "There's a comet in the sky," and I brought them out about 3 a.m. or something because it was well placed. And we looked through the telescope, and they go, "Yeah, good, Dad, sure." And then a year later, the next one came through, and I said, "There's another comet in the sun in the sky," and both of them in unison said, "Don't wake me."
Oh,
There was a great picture somebody took of Hyakutake because it went right up toward Polaris.
right.
And
Mhm.
so in the course of the evening, he took multiple images as the Earth rotated and
Mhm.
made it look like a starburst, like multiple comets coming out around Polaris.
Yeah.
But the main reason we see them, the main stuff in the tail is good old H2O.
Well, it's a lot of things. There's no one. They're dirty snowball, as you've heard. And
Well, I know, but the snowball is H2O, but I can't imagine the sun
H2O
making,
and
making-
CO2,
carbon dioxide also.
ice and dry ice.
And carbon monoxide. And the
Yeah.
green you see often in them is just diatomic carbon gas. So there's all kinds of stuff that glows, that fluoresces.
Well, how about various things you find on moons and planets like methane and ethane? Does that come
Yeah,
out of
that stuff will be solid too, and that will be coming out. Astronomy uses its own terms. Everything other than hydrogen is called a metal when it's in stars.
Is that right?
Hydrogen and helium.
Helium.
Yeah, okay. And then when you take anything, any volatile, and you freeze it down far enough, it becomes an ice. So ice doesn't mean water. If they mean water ice, they'll say water ice rather than just ice. Because ice can mean anything from frozen organic material to water.
And I imagine it exists in the universe almost entirely as ice. Very rarely does it go liquefy. I would imagine only on planets
A
inside.
lot of it is produced in novas, and that would not be in an ice form. That would be
Okay.
in molecular form.
Fascinating.
So it's a
stuff.
vapor.
Well, I want to figure out that curly Q tail thing. I don't get that at all.
Well,
That's-
it's charged particles, and there's a strong magnetic field line there, and they spiral around it as they move.
Yeah. Look,
The right-hand
go to
rule.
Google and put in LORENTZ, Lorentz force, and it'll show you the spiral that you get from charges moving past.
Oh, thank you.
Huh. Okay. We'll do that. So old Bears was the guy that discovered it, or we just put his name on it, I guess.
We just
Oh,
put
he
his name
discovered
on
it.
Oh, he discovered it. Okay.
Okay.
Can I just say something really quick? when you said helium, it reminded me. Is there any update on the astronauts coming back from ISS?
No, they're still studying the leaks.
Okay.
Getting scary though, but they got a little extended vacation in space,
I
guys.
think they have an issue with fuels on board after 49 days of leaking in space or whatever, something like that. So
Mhm.
it'll
They
be
leak
about
away.
a month and a half or something.
Well, gee, I wonder who took this picture of the
This
web.
was a very early on picture. It shows they were just centering. It shows the segmented mirror in space as it was adjusting it. And here there's a star that they're focusing on, and so it illuminates that whole mirror segment. They're tipping and tilting these things until it gets to where it produced a common focus. But it's a cool cool picture.
Yeah. Yeah.
This
Where
bright line here is why you get the large
Spikes.
excuse me, a large diffraction. You get the 6 spikes from all the mirrors having 6 sides, and then you get this one big spike sticking all the way through the star patterns. That
You get 3 spikes from the 6 mirrors because the overlay.
that, yes, but you get every side produces 2 spikes, one on each side. This one produces 2 spikes, one there and one there in the star.
Well, and it's a triple support structure, so you see those 2 below also.
Yeah, but they become, this one is prominent, and then this one is still very visible, and these 2 are very obscure. You have to hunt for them.
But where's the camera located? Out on those arms?
No,
No.
Oh,
This is being reflected off the secondary mirror back to the camera.
yes.
I don't understand. I really don't.
Okay.
The camera's back through the hole.
So we're looking at, oh, okay, if you say so. What is this?
This is
Three-eyed monster.
yeah.
It's a K Jewelers ad.
Yeah. That's good. That's pretty good.
Looks pretty as hell. Is this part of the web? Or is this something web?
These are all taken by the James Webb.
Oh,
These 3 dots and this dot are actually a very luminous galaxy core called a quasar.
Oh.
And it's
Wow.
being lensed. That's an Einstein ring.
Yes. In the way, there's a very massive object that is, I moved the wheel on my mouse and I think I'm scrolling it on my iPad. So just ignore me.
So the
That
form
little
of,
blue dot near the center is the lensing galaxy.
Yes.
so there's 3 versions of it, 3 visions on the top and 1 on the bottom.
Mhm.
Yes. Now, sometimes you can get this is the bright core of a galaxy. There's galaxy around it too. But sometimes you can get an Einstein ring like this, and
It's all the way around.
the path length of the object is different for the different paths. And so an event happens in one of these images, one of the lensed images, and then it'll happen at a later time in another lensed image because one path length is slightly longer than the other. And so if you see a supernova in a galaxy that's lensed, then you can see the same supernova a bit later in the other ones, and you can progress around and you can get the path length difference. Very cool analysis to get the spacings of the thing.
But rather than appearing at noon, 2 o'clock, 11 o'clock a.m., and around 7 o'clock, sometimes they'll give us a whole round, a smile.
Mhm.
Yes, they will.
Or a complete ring.
They can give you a uniform arc. It depends on the mass distribution of the object that's doing the lensing.
And is this rare in the universe or common everywhere?
The 2 objects have to line up exactly for this to happen. And so that is quite fortuitous.
Well,
Yeah, it's rare, but you got so many chances out there that
Yeah.
you see a fair number of them.
I would think with 1 trillion galaxies, it wouldn't be that rare. and a
It's not
billion
that rare.
stars.
They find a lot of these things. Like Chuck
Yeah.
said, it's a low probability, but there's just so many of them.
Mhm.
I think there's a lot more than a trillion. There are more
I think-
galaxies in the universe than there are grains of sand on all of Earth, by order of magnitude.
But when they do these field studies, deep fields, both Hubble and Webb have done it, they try to find the darkest, most uninhabited part of the sky, and yet they find it's full of stuff anyway.
Yeah, they don't want to look at stars in our galaxy.
Right.
Okay, so they go for the Borealis void or any void they can find. They try to look through that.
Yeah,
Aha.
generally up out of the plane of the Milky Way.
Now, the reason they do that is because, as someone once asked a philosopher, how far can you see? And the answer is you can see to the nearest object. And so they want to see things far away, so they don't want any near objects in the way. So they're looking for voids so they can see farther.
It's like the
Okay.
formula for a depth of a well, twice one half the distance from top to bottom.
What is this we're looking at, Mr. President?
This is a very bright star.
Okay, that's
You
obvious.
identify it. And this is the top of the Horsehead Nebula.
Oh,
Now, in this picture, you can see a lot of galaxy. This is taken obviously this is the 6 diffraction spikes of the segmented mirror that we just saw. This is the very bright spike of that top beam that supported it. And there are faint diffraction patterns of the others up here. But these are very characteristic. Whenever you see a picture, if it looks like bright stars look like this, it's a James Webb picture. And if they say it's a James Webb picture and you don't see this, then it's not. But there's a zillion galaxies back here. Nice face-on spiral, another one there. Edge on. This one is redshifted. I'm assuming. Now remember, all astronomical photos are fake colors. They're assigned colors. What do they call that?
right.
Mapped.
They're mapped colors.
Yeah. You can go to the NASA, what is it, Hubble mask, or you can go to the James Webb site, and all these pictures are available to you in raw form. And they're all in a FITS format. And you can't read FITS format in your regular image display software on your home computer. But there is a free download called FITS Liberator, FITS Liberator. It's a free software, and it takes these FITS raw data and it translates them into any other format you like JPEG or RAW or Canon RAW or whatever. And a lot of amateurs do that. Guy, I forgot his first name, but his last name is Bozeman. And he captures all these things from Hubble and James Webb, and he does his own processing on them. Now, you have to be fairly creative in doing that because they don't take, when we do it as amateurs, we're making pretty pictures and we do them in an RBG format usually. So we put them together like the eye wants to see them, like red, blue, and green. Well, the Hubble and the James Webb and all these other things do not take pictures in RBG. They have a large number of filters they put on, and they're selected for certain chemicals they want to see, certain spectral regions or spectral lines. And so you have to be creative about putting them together to give something like a satisfying picture. But remember, that's right. The phrase I was looking for was false color. Everything is false color because you can't see infrared, so you'll never see what this really looks like. And all these colors are assigned by some convention, but very dramatic photographs.
Jerry, when you download these raw images, doesn't that take a whole bunch of free space?
It's some of these pictures are very big. They're very high resolution. It's not unusual for a single frame to be over 100 megabytes.
Okay.
So,
But this is not a drawing.
What's that?
This is not an artist. This looks like a drawing or a painting.
No, this is an image constructed from data.
Did you give the name of this bright star and I missed it?
No, I didn't see that. I was looking for it in my caption here.
It's a star in Orion.
Yeah.
It's going to have some designation. It's not even necessarily naked eye visible.
Okay, but what's stunning about this photograph is at the bottom. I'm curious because I really don't know. Is the horse head part of the pillars of creation?
No,
No, no.
But it's a similar thing, right? They're two
Yes.
separate nebulae. And the horse head, it's turned left, isn't it? Or is it looking right? It's left, I think, isn't it?
It depends on how your mirrors are configured in your
Yeah.
telescope.
Well,
Yeah, that's a tricky thing about amateur astronomy too. And when you take pictures, it depends how many mirrors there are in your system. If you have a refractor with the diagonal at the back, it flips it. And if you have a Newtonian mirror, Newtonian with two mirrors in it, it flips it back. And so you have to, you just get used to seeing the moon one way or the other and not objecting because it's presented so many different ways. Mirror
I
image.
have a roof prism in mine as a diagonal, so it doesn't flip them. And people
Yeah.
look through mine and they say, your image is backwards. I said, no, my image is not backwards. You were looking
Tell
through
a
a
friend in
telescope with a
Australia
mirror
mailed it
diagonal.
to you.
Well, it depends on how many mirrors are reflecting. If it's only one, it's going to be backwards.
But a straight cassegrain like I have has two mirrors. The
Okay,
main mirror and then the secondary.
that would straighten it out. Here we go. Look at this.
These are two views of a dusty disk made of planet formation debris. That is, planets are, this is a ring around a star. The star is very bright, so it's been blocked out by an obscuring or an occulting disk in the system. So its light doesn't overwhelm the light of the dust that it's in. So this is a sun, and this is a rotating planetary disk where planets are forming. They're in process.
And we can look right through that disk from this side.
That's one of the reasons why we look at things that are in infrared, because scattering is very wavelength dependent. It's why the sky is blue, because our atmosphere likes to scatter blue light in preference over red and yellow. And so in space, you see a dust cloud and you can see through that dust cloud by looking at longer and longer wavelengths. For example, radio waves will look right through these things. When you see pictures of Sagittarius A star and you see the planets going around it, or not the planets, the stars going around it, that was taken by a radar array. Or a radio telescope array, because you're looking right at the core of the galaxy and there's an awful lot of obscuring dust in the way. So imaging that is from radio telescopes. This is from infrared, and you can see these are different wavelengths and they give you different clarities of the dust and through the dust.
You suppose they've added the color, or is that how it would really look in ultraviolet and
All astronomical images are false color.
And this is not, there's no ultraviolet here, Ron. This is all infrared.
Yeah.
Oh, both of them are infrared.
Yeah.
Yes.
I thought the upper one was ultraviolet.
No.
Oh, I see. Okay. So there really is part of that disk in the middle. We're just looking through it and it makes a gap. We can see the edges, but we can't see that part that.
No, that part is blocked out, where that dash circle is.
Right. What if the little star wasn't there? Would see the little dot that's the white dwarf?
There would be a big bright blob there that might overwhelm this other stuff up to the sensor.
Okay. And this was taken by the web?
Yes.
Can you guys answer me one real quick dumb question before we leave here in a couple of minutes? I keep seeing these stupid YouTube videos saying the web has detected city lights on the planet orbiting Proxima B, and something must be going on. I must have seen something lit up on the. Is it
you can if you're looking at that on the web, you can block a bunch of pages, and that is just sensationalism for dummies. It's not. Don't listen to that crap.
Yeah.
It's nothing.
Well, I try not to, but I'm wondering maybe it's seeing something and they're just telling us something to get us excited.
If they do see something, I'll track it down, get the citations, and decide if it's real, and then I'll tell you.
Okay. And might we also be privy, Mr. President, to your T Corona Borealis and the asteroid Pallas? What did you call that? Your own observations? You got 2 minutes. Can you call any of that up? You sent it to us online.
Oh, it's difficult. No, can't do
Can't
that.
do it. Maybe in the
It takes
future.
too long. I just
Gotcha.
go with what's prepared here, what I prepared.
Okay, well, what is this?
This is the image of a protostar that is forming planetary disks. It's in the neck of the hourglass-shaped cloud of dust and gas. It looks like an edge on planetary nebula, which does happen, and they do take this form. But this is a mixture of hydrocarbons, ionized neon, and thick dust.
Wow. Otherwise known as the Mae West Girdle Galaxy. Wow, that's
Now,
fascinating.
the color code that they put on this shows these things are very distant redshifted galaxies. They try and keep a logical order to things. Now, this is ultra cool. The next
That's
three
the crap.
things.
No, it's
This-
really hot.
That's it. Good point.
But
So
somehow
this is
they
the
got a
Crab
crap.
Nebula.
Okay.
It's very high resolution. It shows really good patterns. You see these faint lines, swirl lines in here?
Oh yeah.
Yeah. These are dust moving in response to magnetic fields in this cloud.
And there's also the jet from the pulsar in there that's sculpting some of that.
Yeah, the pulsar is right in there. And
Yeah, if you look this in the ultraviolet, that swirling thing is very prominent.
yeah,
And they've determined how long ago this exploded?
July 4th, 1054 AD.
1054, that's right.
July 4th, they have the
Yep.
actual month,
Yep.
long
Yeah.
before we were created.
It was backyard,
1054
backyard
AD,
fireworks.
Ron. 1054 AD. The Chinese astronomers were keeping track of it.
Yeah.
Okay, but interestingly enough, when a star goes from a star to a nebula, it changes the name. But in the center of the Milky Way is the Sagittarius A star, but it's really a black.
A
It's a-
asterisk, Ron. A asterisk. It's not a star. It's
Well,
just a way of designating a radio source. And then they decided it was a black hole. Sagittarius A means the radio source, and A star means the black hole.
And sooner or later, they're going to start finding black holes. And what are they going to call them? Black holes or former
Yeah.
stars? Or put an
They
asterisk?
call them BH something or other with a number.
Yeah.
Okay.
And going back to the Chinese system, you got to remember the Chinese had a continuous civilization, not that they didn't have wars, but for 5,000 years. And they have a recorded history of all that stuff. It's not like the West here where we had a dark ages and things where ancient knowledge was lost and burned and stuff.
Yeah.
So they have a
Did they
lot of record keeping.
Did they get dragons from dug up dinosaur bones, you think?
Could be.
That's a whole topic by itself. The ancients used to, in our Western culture, they would find mammoth skulls and they thought they were giant cyclops. So that has a large nasal cavity and they took that for an eye orbit.
We do have a constellation of a dragon, don't we?
Draco.
Right, Draco.
Draco.
Did
Yeah.
that come from China?
No.
No.
It
The
didn't.
Chinese
No, the
have a lot
Norse-
of little tiny constellations.
Yeah. The Norse had a history of dragons. They call it Draken.
Well, there's a lot of myth up there. The unicorn that we saw earlier, you know.
Yeah.
Well,
Okay,
gentlemen,
now, yeah.
one last shot. Go ahead. What is this? I saw this earlier, didn't we?
This looks like a Webb deep field or
These are supernovae identified by the James Webb Telescope.
You're kidding. Every one of those blue circles is a supernova
Yep.
going
Wow.
off in the
Wow.
middle,
These
inside.
these are examples of the most distant supernovas ever seen.
Well,
Hell,
more YouTube videos coming my way about that. God knows what they'll say. Hey, gents, you did me in again. I learned what's the word for occulting a star? Intro and outro. No, what are those? It's
ingress and egress.
ingress and egress.
Right.
Sounds like a comedy team.
And the last picture
Okay.
is of lensed galaxies and mirrored star clusters.
Wow.
Oh, for crying out
So
loud.
this is the foreground galaxy cluster with a redshift of 0.97. And this little region with the little two streaks in it right here is blown up by James Webb into these. This is a lensed galaxy with a redshift of 2.6 here, whereas this stuff is redshift 0.97.
Right.
And then it's a lensed galaxy redshift of 10.2 shown here, and these are mirrored star clusters
Jeez.
in the galaxy and at a redshift of 10.2.
And Ron, don't forget that the bigger number means further away,
Yeah.
further away.
The farthest thing away they've seen, as I recall, is about 14.2 redshift is Z value.
Yeah, you showed a Z14 a week ago or 2 weeks ago, and I translated that into how far away it was, how fast it was going. It's incredible.
Yeah.
Is the Z, is that in terms of like billions of light years away?
No, that's wavelengths of light.
Yeah. Yeah, Tim, the Z is cosmological redshift. So it's what they used to designate cosmological redshift.
But it's
A
13
redshift of 0 is Alpha Centauri.
Right. It's at home.
Yeah.
Sounds like we got lots to talk about in the future. I guess we can go over as long as we want because that's how YouTube videos are. They're any length you want. Gentlemen, you did good. Tomorrow is the Tuesday Star Party out at Camino Real. Saturday, we have our board meeting at 4:30 online. Everybody's welcome to join. And then Saturday night, 8:30 for the darkness. 8 o'clock, we'll get there. Take care of yourselves and your wives. And thank you very much for a great potluck. Thank
Yeah.
you, Diane Welchenbach, for